Here's an example similar to question 2, assignment number 6, where you have an implicit function and you have to find a higher derivative. So I'll do an example. It's pretty similar, and I'll pick a function, say x squared plus y squared is equal to 9. And you're asked to find the second derivative, d squared y dx squared, or if we want, y double prime. Now again, you may recognize this as the equation of a circle, and you can certainly solve for y here, find its derivative, dy dx, and differentiate again to find the second derivative, which is d squared y over dx squared of y prime. But I'm going to do it using implicit differentiation. And what does that mean? Well, essentially, we differentiate every term with respect to x. So here, the derivative of x squared, of course, is simply 2x. The derivative of y squared is going to be 2y dy dx, or simply y prime. Again, we're differentiating with respect to x. And the derivative of 9 is simply 0. Now, it's amazing that how many times people forget that the derivative of a constant is 0. And sometimes the common error is to put in 9 here. So now we'll solve for y prime. You're going to have 2y, y prime is equal to negative 2x. And you can cancel the 2's here, but essentially what happens, you end up with y prime is negative x over y. So that is the first derivative. Pretty straightforward algebraically. That is an x, by the way. So what we have to do now is to find the second derivative. And we're going to use the quotient. Now you can leave this negative sign outside if you want. You can group this together. I'll group it together. So y double prime, or d squared y dx, is the following. So using the quotient rule, it's simply y squared. It's the bottom term times the derivative of the top term. Now again, this negative sign here could go outside, but I'm going to leave it in, so something's going to be negative 1. Derivative of x is negative 1. Minus the top term, which is negative x. And you got to be a little careful here with the negative signs in the algebra. Times the derivative of the bottom term, and derivative of y is simply y prime. And in essence, this is the derivative, the second derivative of our function. What we're going to do now is substitute in for y prime, and y prime is this function right here, which goes in here. So simplifying, we're going to have negative y plus x times negative x all over y. Again, this is the y prime term here, and this is substituting in all over y squared. I'll tie up a tiny bit. Y squared for y minus x squared over y all over y squared. And now we simplify. And this is probably the most challenging part of these type problems. You get a common denominator on top, basically multiply by, if you want, y over y, but my LCD here is simply going to be y. So I'm going to have negative y squared minus x squared all over y divided by y squared. Now if I simplify it, I can take out a negative from the numerator and have negative outside of y squared plus x squared over y times, again, 1 over y squared. I'm putting all steps in here. Now you can simplify this different ways. Whichever you're most comfortable with is fine. And I end up with negative. Now you notice that this term right here is our original equation. If you go back, x squared plus y squared is equal to 9. So I substitute in 9 here. That's the key step. So you're going to have negative 9 all over y times y squared, which is y cubed. And that's how you find the second derivative, giving a function like x squared plus y squared is equal to 9. And that's how you can do the questions 2a and 2b.